Okay, and then I open the floor for Walter Hoshort, who will be our speaker today. So, Walter, the floor is yours.
Thank you very much, Fernando. First of all, good morning, afternoon, or even evening to you all. Thanks for the large participation in this webinar. My name is Walter Hulshorst. I'm living in the Netherlands. Today's webinar about small-scale wind energy, it's just an introduction and it's based on a manual I've written about 1 year ago, which you can also find on the Leonardo Energy website. Based on that manual and the number of downloads, we thought it would be very good and attractive for you to have a webinar based on small-scale wind energy. Today, as Fernando already told you, I will tell you something about general information about the small-scale wind energy, just an introduction. After that, Fernando will present you the RETScreen case studies. So the agenda for this afternoon, evening or morning, depends on the time where you are. We will start with several types of small-scale wind energy systems we have around the world, and how you can estimate your energy output. After all, if you have a small-scale wind energy turbine, you would like to have the output to be energy. Well, as you will find out later on, it will depend on the wind speed you have, and that depends also on the location where you will add your wind energy source. And after that, Fernando will continue with a case study, which is RETScreen. So let's first start with what actually is a small-scale wind energy. Well, there is a definition in the IEC 1400. That says that turbines with a swept rotor area smaller than 200 square meters are classified as small wind turbine, and you have to know that the swept area of a rotor I've shown in the picture on this one, it's the red dot area, which is the area which should be lower than the 200 meters. In general, I think there is also a non-universal definition, and I think that's the one we mostly will use. It's saying it's based on the kilowatts the small wind energy is producing, and in this case I've added a system about smaller than 100 kilowatts, so it will start from a few hundred watts up to 100 kilowatts, or sometimes you will see 50 kilowatts or even smaller. Wind energy, well, it was first, I think it started about with the yacht or boats applications. It was used for, mainly used for battery charges on boats, so you can use your radio on a boat or the lighting of the boat. After that, I think most of you will recognize that wind energy was also used for remote areas. They are mainly off-grid systems, and I think most of you will recognize weather stations at some areas where you can't see, where you don't have electricity and you want to use a kind of wind turbine. You can also not only use the wind, but in some cases you will need, for instance, a battery or a wind combination of wind energy with PV, with solar, or wind with diesel generation. That's also an opportunity. Nowadays, I think the small-scale wind is also used for grid connections, and I think if you look at it, most of them will be used in an urban area where you have your grid and you can easily connect it to your grid. Basically, when you talk about the system of small-scale wind energy, you have two types of systems. The one is a horizontal type of system, which is shown in this picture. You mount your wind energy on top, on the roof of your building, and horizontal means that the axis of the rotor is placed in a horizontal situation. Well, you also have another situation which is called, you can expect it of course, the vertical situation, and there you have that the axis is in a vertical situation. Both have their advantages and disadvantages, of course. I think most of you will recognize the horizontal types, especially the larger wind turbines. They only have this kind of type. Well, also I found a nice one which is somewhere in between. I think this one does have a horizontal axis, as you can see, but if you look at it, it's not the way you see the horizontal types of turbines. Well, following situation is also very interesting at this moment. You can make your wind turbines mounted on top of your roof, but you can also integrate it into buildings. This picture is taken in Bahrain. It's a building it's a building which is situated on this side, and here you'll see three turbines which connect the building between two buildings. And I think the next slide will show you something more. This is in the evening is the picture taken, and you will also see that over here you have one building, and over this side and between them you will see integrated three kind of wind turbines. Please note also that the airflow from this side is try to optimize as much as possible, so with no obstacles between it, so the airflow can go between those two buildings very easily. I think this is also a picture, the next one, which shows you an integration of the wind turbine into two buildings. And very recently I noticed on the internet this one, although it's not integrated in a building, it's integrated in a road. It's very nice, I think. Normally you will see that on top of the road you will see the direction which you have to drive, and now you can see also a wind. Nice to see. If you go a little bit further, well, what kind of wind turbine do you need for your situation, and how can you estimate the power of a wind turbine or the energy of a wind turbine? What we need when you buy a wind turbine is of course the wind turbine specifications. They have several types of specification. I will go through the specifications I think you will need the most of it before you want to buy. In this situation I've added three types of wind turbines and compare them with each other. I have a smaller one which has about 1 kilowatt rated power, a 2.5 kilowatt power, and one 10 kilowatt rated power. And on this picture on this side I've added on the horizontal axis the wind speed, which is done in miles per hour but also in meter per second, since I noted that a lot of people are talking about meter per second while other ones are using miles per hour. And on the vertical axis I've added the power output. And the power output depends on the wind energy, as you can see in these graphs. I've added the blue one, which is for the 10 kilowatt machinery. The green one is the 2.5 kilowatt machinery, and the red one is the 1 kilowatt machine. You will see that they have a different output of power, and I think the first thing you will notice is that with low wind speed, the output for most of the situations is zero. And at a certain point, wind speed, the energy, the output is going to start, and that's called the cut-in wind speed. Most of turbines, I think most of them will have about between 2 or 4 meter per second where they will have a cut-in wind speed. If you buy a turbine and you have to compare some of them, well, please buy the one with the lowest cut-in speed, because at lower wind speeds it will already start with giving you some output. You will also notice that at a certain wind speed the output will be the rated output. If you have this type of situation, this type has an output of 10 kilowatts, but you will see that the output is only 10 kilowatts when the wind speed is about 25 miles an hour, or about, well, let's say 11 meter per second. You will also see that for the other types of wind turbines I've given you, that it will be about the maximum output about 2.5 when this one is about, well, let's say 27 or 28 miles per hour, or 12 meter per second, which is almost similar for the one with the 1 kilowatt. So it means that between the cut-in speed and between the rated wind speed, the power of your wind turbine is not the rated power, but somewhere between it. And you can also see it on this picture. If I have, for instance, the blue dotted line and my wind speed is about 10 miles per hour, I will see that I have only 1 kilowatt output. If I double my wind speed to 20, miles per hour. I will notice that I have about 8 or 9 kilowatts output. So it means that you can see easily that if you double your wind speed, you will see that the output between this area will be cubical. So that's very large impact will it have. You will also notice that there at a certain point when the wind speed is larger and getting larger, that this wind turbine is not going to give you any output over there. So basically for this situation we have a cut out wind speed which is about, well, let's say 15 meters per second, or it's about 35 miles per hour. So if the wind speed is higher than that value, you won't get any output from this wind turbine. The other wind turbines are still running. They are still producing the output. Well, you have to be sure if you want to buy a wind turbine. Well, I think it would be very nice if you bought one with a very large cut-out speed. Please note that some of your manufacturers will say that they don't have a cut-out speed. Be careful with them, because if the speed is getting higher and higher, the wind turbine could give you some output, but certainly if your tower or your wind complete construction cannot fulfill those wind speeds, then you sure will have some problem with it. So I think it's very nice that you know that between the cut-in speed and the rated power, you have to know that you will not give your full output, and the full output, the rated power between the cut-off power will produce you the rated power. So you will also see that between the cut-in speed and low value of wind speed, you will not have any power. So basically, when you want to buy a turbine, you have to make sure that you know something about your wind speed and your location. And to estimate your annual energy, I told you need the power curve of your wind turbine, and you need to know the wind distribution. So most of your wind distributions can be described as a Weibull distribution. In this example, I have on the horizontal axis the wind speed, and on the vertical axis the numbers of hours each year the wind speed will occur on this location. And you will see that that for instance at a wind speed of 7, well, just between 6 or 7 meter per second, this will be the average wind speed you have on this location. So please note also that if you have a power curve with a current speed which is about 4, then every time, most of your time between the 0 and the 4, and within this area you won't have any output for most of your wind energy sources. So take care of your wind speed on your location. It's also important that you know, when you have such a Weibull distribution of a location, that you know at which height the distribution is given to you. You can easily, it's easily to say if you have a wind speed at low, let's say 1 meter from ground level, your wind speed will have more turbulence than you have it at higher locations. So it makes difference if you have measured your wind speed at, for instance, 50 meters, or you measure it at 1 meter. The higher you go, the less obstructions you have, so the wind speed will be higher at higher locations. That's also one of the reasons why you see that most of the wind turbines are getting larger and larger and higher. There's only one restriction with that. The weight of your generator is also, well, when you make it higher, you will have some problems to get your generator at that height with those tremendous weights they have nowadays. If you look at the small wind turbines, you will see that compared to the large one, you will see that the smaller ones require less wind and land resources than the larger ones. So their installations is feasible for very different locations. Small wind turbines are, well, can be used especially for urban areas compared to the large turbines, but there are some constraints. In general, we have at urban areas, we do have compared to other areas a lower average wind speed. There's also more turbulence due to buildings or trees over there. And there is also a possibility that you could get some difficulties with obtaining planning permissions for your wind energy. So if you look at the differences of the wind speed, I've given you a picture of a 10 kilowatt energy system, which and you'll see the impact on the terrains. On the horizontal axis, I've given you the annual energy produced with this 10 kilowatt wind energy system, and on the vertical axis, I've given you some areas. You will notice that the coastal, where we don't have any obstructions or less obstructions, you will see that the energy produced is larger compared to the situation where we have a suburban area where it's very at the lowest position at this moment. So that's a difference between small scale wind energy, which is often used in in urban areas, compared to the large wind turbines, which you will often see close to the coast or in open farmland, which is, well, I think logical if you see this picture, because you get a higher output over there. So for your location, there are some aspects which you have to 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 cover. First of all, your energy output depends on your wind speed. So go to a situation where your wind speed is high enough. Otherwise, if you have a location where your wind speed is less than, for instance, 4 meters per second, well, it doesn't make sense to have any wind energy system over there, because the cut-in wind speed is almost in most situations lower than the 4 meters per second, so you won't get any output. There's also attractive that the wind speed increases a little bit when you have on the top of a building, and when the obstacles when the air has no obstacles. So if you place it on that kind of location, you will see that the wind speed is a little bit higher, which is attractive for your location for your wind turbine. Also note that yes, obstructions like buildings, trees, they do have effect on your wind speed and will reduce it. So please try to locate as far as possible your wind energy system from any obstacles. If it's not possible in an urban area, well, then you have to go at higher to go in the height. You can increase it to compensate your lack of distance. And I think this figure will show you a little bit, although it's a very general picture, but it will show you the effects of a building or a tree. On this side, you will see over here, you will see an obstruction, which could be a house or a building or a tree, and you can see with the blue area, which is this one, which does have some turbulence if the wind speed is coming from this direction. And you will also see that if you have a height which is given in h, you make sure that your wind turbine is not within 2 times the h before this obstruction, and also about 20 times that 20 times the height in this situation. And if you go higher than two times the height, then you will see that above this area, well, the obstruction doesn't have any influence on the wind speed. Perhaps it might have a good impact when you place it over there, because all of the energy will go, wind energy will go over this situation. So it could be used also. There are also some other issues when you deal with wind turbines. Make sure that your wind turbine is located closely to a point where you can use your energy which is produced by it, or close to a grid connection, so you can feed in your electricity back to the grid. Be sure that if you want to use a small wind turbine within an urban area, that noise and visual impact are also topics which you have to deal with. They are, well, I think most of them will be subjective, although you can measure the noise. Younger people, older people will have will react different on noises, so you should be careful with it when you want to buy a wind energy system within your area. Please also inform your neighborhood when you are going to do it before putting it on your roof, and then after that you will could have some troubles with your neighbors. If you want to know some more information, I've just told you I'm only giving you a small introduction of small wind energy. There is a lot more to tell about this topic. But so if you want some information about general information, well, of course I should have some commercial for the Leonardo Energy, so you can go to that website. Also know then that there are some websites with wind manufacturers in Europe, so you can get some data from wind turbines, prices, and also the curves of the power curves. And also, if you want to know something about your wind speed, it's also you can collect it on the wind atlas for this site. So basically, I would like to thank you for the presentation so far. I think you will, with Fernando will continue now with the presentation from the RETScreen. So thank you
Okay,
so
Walter,
far.
thank you very much for this
Fernando, the
brilliant
floor is yours.
presentation. Very interesting. So now I suggest sharing my screen and then going across RETScreen software. Well, so now you should see this Excel sheet, which is the RETScreen model. So let's proceed in the right way. So here in RETScreen model you have possibility, well, of course, to name your project, to specify the location and other issues. Then the first point to see is clicking what kind of project are you going to analyze. Then on a RETScreen you have several possibilities: heating, cooling, combined heat and power. Well, in this case this is simply power. We have also possibility to choose which kind of power. So we have wave power, tidal, steam turbine, solar thermal, and other. So in our case it's wind turbine. Okay, so we click on wind turbine. Also there is possibility to analyze isolated grid, off-grid, or central grid. So we will remain focused on a grid-connected application. Analysis type, well, you have two levels. So first level, first approach; second level, more in depth. So we start with this. Heating value reference, well, this is only relative to heating or combined heat and power projects. So we can choose the language, the currency. So we use euros in this example. Then units, the metric units. For site reference conditions, we have a database. Then by clicking we can choose the country. So we choose United Kingdom, and well, particularly windy location in Scotland. So we have good wind speed there. Not so much radiation, solar irradiation, but there is a good wind speed. So we click OK. Then we have the possibility to see the data. So latitude, longitude, elevation, and then these features, let me focus. We have the daily solar irradiation, but we have here the wind speed with very good wind speeds. In January the average wind speed is 10 meters per second, which is pretty high. And then for the rest of the months, and this is a measurement at 10 meters from the floor, from the ground. So at this stage we have completed. Then we go into the energy model. Then we have three levels of analysis. So we have method 1, 2, and 3. We are now seeing the method 1. So for method 1, we should indicate what's the power capacity of this wind turbine. So we have chosen, well, let me show. We have a product database. Okay, so if we click on product database, we have a good library. So we have chosen Bergy Wind Power, which is a wind turbine shown in the presentation by Walter. So here we can see the power curve data. Then we see how the cut-in speed is about 5 meters per second. Then it starts providing 1 kilowatt, then increasing up to roughly 15 meters per second. Between 13 and 15 meters per second it provides the maximum power, and then it decreases, but the cutoff speed is quite far. So we are sure that with high wind speeds this will produce, even if it's lower than optimal speed between 13 and 15 meters per second. So we can choose several units, but we will choose one unit of 10 kilowatts. Then we click OK. Then coming back to our model, then we have automatically introduced what's the height of the hub. We have one unit, the height, the brand. So we have to introduce manually what will be the capacity factor. Well, in this method we don't have we have to figure out what will be this capacity factor based on average wind speed. In method 2 and 3 we will have the opportunity to introduce wind speeds per month, average wind speeds per month, and then having a more precise and more accurate estimation of capacity factor. Capacity factor is roughly how many hours equivalent full load will run the wind turbine. So in this case, electricity exported to grid will be 26 megawatt hours per year. So here we choose what's the electricity export rate. In this case we have chosen the average electricity price for United Kingdom for domestic users. So this wind turbine will avoid the expense of electricity. So base case system, this is emission analysis. So as for emission analysis, we have the possibility to compare what will be the avoided emissions. Then in this case we can choose what kind of fuel is alternative 1. So if we choose coal, which is quite carbon intensive, we find a ratio of 0.8 tons CO2 per megawatt hour. If we add transmission and distribution losses, then we are close to 1 ton per megawatt hour. Well, this is probably one extreme assumption. We can choose other technologies like natural gas. In this case, we will be roughly at 0.4 tons per megawatt hour. So based on that assumption, we find 11 tons of CO2 as avoided greenhouse gas emission. It's equivalent to 2.2 cars on light trucks, but we can also choose other ratios like barrels of crude, which is 22, or hectares of forest absorbing carbon, 3.8. In the case we have an income because of greenhouse reduction, this is very interesting for countries not included in Annex 1 of Kyoto Protocol, which are eligible for clean development mechanism project. So in this case you could introduce here the market price for your carbon credits. Currently it's going down, but you could assume prices like 16 euros per ton today. Then in this case you should also introduce your duration, let's say amount of years for the project, 15, and then the reduction credit escalation rate. So in this case you choose a number. We will choose 0. In this case we are in UK. Well, you could participate in the voluntary carbon emission market, which is much cheaper but growing. And then we go across financial analysis. So you introduce in this case your inflation rate, project life, so we choose in this case 15 years. Debt ratio, if you go to bank, well, not the best time now, but if you can have 80% finance at let's say 5.5 debt interest rate during 12 years. What's the initial cost? Well, small wind, it has comparable costs to photovoltaic system. So for 10 kilowatts we would be around 40,000 euros, 50,000 euros. So many countries are introducing incentives on investment for small wind systems. For instance, in Spain, you can have up to 3 euros per watt, which means in our case with 10 kilowatts you can have 30,000 euros for your project, which is a pretty good number. Then in this case, well, we have assumed a rate of subsidy of about 15-20,000 euros. Then in this case we have to invest 35,000 euros. Well, we do not introduce other incentives or grants. We assume 500 euros of operation and maintenance annual cost. Then based on this, and based on the prices we have indicated previously for the electricity production, we have this electricity export income, which is 4,000 euros annually, slightly more. Then in this case you can see here the cumulative cash flows graph, where you see how you have a payback time based on your equity of about 6 years, which is interesting investment. Well, it all depends on what's the amount of your investment. If you have to assume the full investment, let's say 45,000 euros, then in this case you start recovering your investment in almost 12 years. So it will be more on voluntary action if you don't have any other incentive. Well, we can see now very quickly, in order to let more time for discussion, you can of course send your questions during the presentation. Do not hesitate. We will dispatch them during the Q&A session in about 5 to 10 minutes. If we choose the method 2, then in this case we have to choose whether we are specifying wind speed. Then in this case we have the possibility to see maps. Then the next step is wind speed, the annual value. So we have this average for this location we have previously chosen. We have this average wind speed on annual basis. So you can type it manually. Otherwise you have also the possibility to check the values. Be working, so let me show you. This is method 2, 3, method 2. Okay, so in method 2 we specify an average annual wind speed, so 8.2 meters per second, measured at 10 meters high. So in this case we should also specify the average air temperature, the atmospheric pressure. Then we define, as we did previously, the power of our the nominal power of our wind turbine. We have chosen this model, one turbine, 10 kilowatts. The hub height is specified at 18.3 meters, so in this case we can benefit from a higher wind speed. So we have the area per turbine. Then RETScreen software provides with the expected generation for each wind speed. So these wind speeds come from the database for this particular location. So we have for 5 meters per second we have this generation, and then the best ratios are comprised between 13 and 15, because here we have the maximum output power. Then in this case, using this more accurate method, we find a capacity factor slightly higher than we previously used, so 39.9. Well, I can assure you this is an excellent location. Usually project let's say big wind capacity factor is about 25% capacity factor. So the export electricity rate, we can either choose this price, which is let's say wholesale market price, but we decided to introduce 166, which is the household electricity price. So again, emission analysis, we don't need to come back. Then in this case we see how with similar project ratio about finance, we can afford for a higher investment, 50,000 euros, because we have a much higher production. This is definitely this changes definitely our financial figures and our economic figures for the project. Payback time in this case it's about 7 years, but I can afford without the need of any subsidy. So in this case, with these high wind speeds for the north of UK, this according to RETScreen analysis, we would be in economic rate for a small wind project. Well, so now we are coming back to our presentation. And we can open the floor for questions. So please, you're invited to submit your questions. So we have a first question from Fritz Og. Guys, the pods now. Good. So what's the absolute minimum average yearly wind speed in urban areas to consider a small windmill? And what's the best way to measure it? So maybe Walter, I leave you the floor. Thank you.
Thank you, Fernando. Well, based on your question, I will go a few sheets back, and I think that will answer partly your question, what will be the minimum wind speed? I think this presentation covers it all. The wind speed should be higher than your cut-in wind speed. So if it's lower than, let's say, between 2 or 4 um, meters per second, then it doesn't make sense to have a wind turbine at that location. If it's getting higher, then you might think about a wind turbine. If you look how to measure it, well, that's yeah, a good question. You can measure it by have some measurement equipment and put it on your roof and measure it for a couple of months, preferably 1 year. Well, I think if you don't have it, then you should try to get some information from weather stations or in the neighborhood of your location. I hope that answered your
Thank you,
question.
Walter. So next question comes from Costas. How accurate is the use of data coming from the weather maps? Well, as any other preliminary estimation of the wind potential, it's good for a first approach. If you are considering installation of a small wind turbine, you should consider carrying out some measurements. We have seen how the sensitiveness to wind speed is a cubic law. This is shown now on the presentation. So you need absolutely to carry out some measurements, or at least to have access to more, let's say, local service of wind measurement. If you want to add something, Walter, you're invited.
The main thing about if you have data should be accurate enough. If you have error of 10% of your wind speed, then you have noticed that the deviation in your power could be cubical, so it will be 33%. So it should be very accurate as possible as you could
Okay,
get
good.
it.
So we have another question coming from Costas again. Coming from Nitin Bandit. Are vertical axis small wind turbines commercially available and usable? So if you have any feedback on this market figure, Walter, I let you introduce the question. Otherwise, as Walter indicated, there is a website called All Small Wind Turbines, where you can find any kind of wind turbine. Anyway, I let you the floor, Walter.
They are available, although the vertical ones are available. I think Fernando mentioned all different types of vertical axis wind turbines, and they are also usable at this moment. It depends a little bit on your location, where you sit. Horizontal and the vertical do have both. Do have some advantages, but also some disadvantages. Perhaps I think the vertical ones are mostly they will have somewhat lower noise level, and also there could be some feasibility issues, visualization. They could be nicer to see than for instance the horizontal one. But that's just some aspects which could have some influence. To go back on your question, yes, they are available. If they are commercial available, go to the website we mentioned before, and perhaps you can find out for yourself if they are available. Please note that the output of vertical systems are in general lower compared to the horizontal one, I think.
Okay, good. So still on vertical turbines, we have another question from Jaime Negron. How do the power curves from vertical compare with the horizontal ones? As a first feedback, vertical ones are not as efficient as horizontal, as general rule. You can have some additional elements on this small scale wind turbine manual, how-to manual. I will forward you back the link to download it. However, again, Walter, you have certainly more elements. Thank you.
Well, I think you mainly said it before already, Fernanda. So, well, there's one big advantage about the vertical system compared to the horizontal one. I think if you have the wind direction, doesn't matter from which side it comes. Okay. Vertical situation, you can see whatever the direction might be, if the wind is flowing from this side or from the other opposite side to there. This one will still move. If you go to the horizontal system, you will need a tail vane to which indicates which will show you that the wind turbine is going to the good direction to have the optimal speed at this location. So the only thing I can add to your answer so far, Fernando.
Okay, thank you. So now we have a question from Tadeusz about cutting speed. Is the relatively high cutting speed a result of the need to produce commercial LV quality current? In Poland, most of small-scale wind systems are homemade and directly coupled with water boilers, as hot tap water is very commonly required standard. Are there other turbine designs usable at lower wind speeds? Well, in my view, cutting speed is first of all a, let's say, aerodynamic issue. But well, Walter, I let you the floor whether you have more information on higher or lower cutting
In general,
speeds.
I would say everyone would like to have a cadence speed which is as low. Things you have to do with some physical elements of the system. You will need some power to have to move the vanes, for instance. So that will be needed also within your system and can be seen as a kind of losses within your system. Special systems for very low wind speeds. Well, perhaps they are available, but I think the power output will be very low compared to the other systems. So I'm not quite sure they are available, but I think if they are available, the output will be low.
Right, thank you very much. So we have another question from Sergio Ferreira. Are vertical turbines more appropriate for urban settings where there is more turbulence? Walter, the floor is yours.
I'm not quite an expert on that. I'm not quite sure. I cannot answer this question right away if it make any sense between them. Perhaps you, Fernando. I also noticed that we have so perhaps they can answer this kind of questions. I should try out. I should find out.
Yeah, thank you. Sorry, Walter. Okay, yeah, well, in general terms, turbulence is definitely not the best regime for wind turbines of any kind. Well, we know this question, interesting question, and then we'll get more information, or we will post as a comment. Thank you. So now we can go with the next question from Aidonopoulos. Can you suggest an affordable wind speed measurement tool for small installations? If you have any information about this, Walter,
It's
thank
a
you.
nice question. You can discuss what is affordable. Well, as already mentioned before, you can buy, for instance, an installation which could measure your wind speed, and you can also hire one. If you buy an affordable, please note the accuracy of the system. As mentioned before, if you have an error of 10%, you will have a deviation of 30% in your power output of the wind turbine. So you should be very careful when you want to measure your wind station, what kind of installation you will need. So depends on what affordable is for you. In case you have, I would recommend you to hire some system if you.
Right, thank you. So now there is a question by Mark Miles. I have a small turbine on a site on a very large lake. Would locating the turbine fan at low altitude just over the lake surface give comparable power without need for a high tower? Well, from this point of view, you've got what is known by wind shear factor or exponent, which is whether the height is relevant uh, depending on the kind of surface of terrain. So on open water, indeed, this exponent is 0.1, which means that there is small influence on the height. So if you have a very large lake, indeed, there is probably few reason for growing up your height. Contrary to this, if you are on a hilly or mountainous terrain, if you are in a constructed environment with several buildings, or you have heavy trees, in this case you have definitely interest to grow in height, because in this case the wind shear exponent is 0.25, which means strong influence on the height. So yes, as you suggest, influence of height is much lower than for the rest of terrains. Obviously you will always gain some power by reaching more height, but this is usually constrained. Then be sure you are not losing a lot of power, not as much as in these environments I described before. I don't know if Walter has anything else to say about this. Walter? Okay, so now we can go to other questions. So next question coming from Jose Reyes. How to consider the wind direction with RETScreen? Well, I'm not sure direction is considered, but RETScreen just take into account the global wind speed regardless from direction. Thank you. So we can go to the next question. Francesco Padovan is asking whether the manufacturer published power curves are reliable. Well, I don't have this feedback. Maybe Walter, do you have any other feedback from the field?
Well, in general, when you talk about power curves output, if you do them from a manufacturer, please note that the curves are well, I think they will mention within a laboratory or something like that. So if you go to your field location, you will see you also always have some turbulence. So you might find out that your curve in the field will be a little bit lower or else than the one the manufacturers could have give to you. So then could be some kind of mistake with which well, actually it's not a mistake, but it's based on the methodology you used for making those curves.
Thank you, Walter. So next question from Jimmy Aranibar. Do you know how much is the investment cost by kilowatt installed? Well, as a general guideline, you can afford for similar costs as of installed kilowatt of photovoltaic system. How much is it? Well, around 4 to 5 euros per watt, which means 4,000 to 5,000 euros per kilowatt installed. I don't know whether currently these costs are going down, or do you have any additional price guideline, Walter? Thank you.
In general, I would say if you talk larger wind turbine, lower compared per kilowatt than the smaller ones. So in general, the prices of those, I think the 4 to 5 euro still the price I think it's which is nowadays can be used. And if you go to the website which is mentioned in the windturbines.com, they will also give you an overview of the prices.
Right, thank you, Walter. So we will go to the next question. Coming from Amjad Ali. How we can control overcome friction in the wind turbine if wind speed will be more than 10 meters per second? I suppose your question is relative to what happens when we reach the nominal power, and then what's the safety device to protect the wind turbine. Can you tell us more about this, Walter?
I'm not sure what it. If you suppose that about 10 meters per second you have the rated speed, or then you will get your rated power, and well, I think 10 meters per second. Most of the wind turbines will have no. They will have your rated power at that wind speed. Most of them. If you go higher than the 10 meters per second, and then well, you should be sure that your wind turbine is in a safe mode. If you have higher wind speeds, your direction of your wind turbine should be that way that that it don't break down at the kind of wind speed. So it should be in a safe mode at that moment, at that kind of wind speeds. I hope that's an answer of the question you asked.
Okay, thank you, Walter. What I can say about this is, well, for big, very big wind turbines, protections are acting on the blades directly. So blades are positioned in a shape that they cannot keep any energy from the wind. In the small scale wind turbines, for sure there is no this blade orientation. So just by let's say aerodynamic inefficiency, the wind turbine cannot provide more power. So in this case, it's let's say self-protected. So we can go to the next question. So we have a question about how to build the tower that supports the wind turbine. Is there any website where we can find this kind of information? Well, in this let's say briefing webinar, we didn't care about let's say construction issues, particularly the tower. There are some models provided with a guide to mount. I mean, the tower is provided, and there is also let's say a manual on how to build this tower. Usually for small scale it's feasible with no special tools. Maybe you, Walter, again have additional information on this?
Sorry, Fernando, I don't have a website where you can find it, but most of cases I think you can ask your manufacturer about building of that tower that supports your wind. Well, I see also that Mr. Leslie Dumont has already mentioned a website where you can find.
Okay, thank you very much. So I'm trying to go to the references. Yes. So you will probably find interesting information on this website, allsmallwindturbines.org. Many manufacturers provide how additional information. I see how in the introductions window there is reference to otherpower.com, other power wind towers. So thank you very much, Joe, for this reference, and you can use also this website. We note this is all very interesting questions and feedback to provide more additional contents on this issue. So next question is about CDM methodologies for carbon calculations. Well, this is a completely different subject, but I have good news for you. We will have soon a CDM dedicated webinar where we will focus on all these clean development mechanism projects. We will go across some examples carried out in Latin America. So we will be pleased to let you know more about CDM methodologies by experts currently working on this market. Thank you very much. So we have well, we have definitely many questions. So I think we will address just 1, 2, or 3 more, and then we should be well, closing this webinar for today. The rest of the questions will be further addressed in a, let's say, our website will be published the presentation, the recording of this webinar, and all the questions that today we cannot address because you seem very interested by this item. So we note this is an excellent feedback for us. So your questions will be addressed ex post in our website. So please visit Leonardo Energy and then discussion webinars. Then you will see there the upcoming ones, but also the past webinars. And then in about 3 days we will publish this presentation the recording and the rest of the questions with a tentative answer. So let's address the last question now. So Philip has a wind turbine, an average wind speed of 6.1 meters per second. He's thinking of installing a 6 kilowatt proven wind turbine. Would it make more sense to install a small turbine that will work more efficiently at that speed? So, Walter, I'll let you answer.
Well, I don't know the power curve of your type, the 6 kilowatt proven wind turbine, but mainly, well, in general, if you have a 6.1 meter average wind speed, so you need to know the distribution of your wind speed. It's already mentioned if there is a variation in your speed, the power output will be cubical. You also, if you have your rated power of your proven wind turbine at 6.1 meter per second, then I would say, well, use that wind turbine. But I don't think that the rated power will be on that level, because the wind speed is very low for the rated power. So if it makes sense to use a smaller wind turbine, it could be if your smaller wind turbine, if you could locate it at a higher height, then it could make sense, because then the output will be higher because you have more wind speed. So that means that you also can use a smaller wind turbine. And it could also be interesting to use a small wind turbine if at 6.1 meter per second your smaller wind turbine has already the rated power, while the other one, the 6 kilowatt, for instance, doesn't have at that location at that speed the rated power. So it could make sense. You have to compare both of the power curves and also your wind distribution to have that answer.
Okay, thank you very much, Walter. So now we will address the very last question coming from Jose Reyes. How does the density of the air affect the efficiency of the wind turbine, for example, in a mountain? Well, density of the air affects directly, obviously, the power available from the wind. You can test this effect with RETScreen module, where you have the possibility to introduce the atmospheric pressure of your location. So atmospheric pressure influences directly density of the air, also temperature. Maybe if you are in mountains, you have less pressure, but also lower temperature, which is good. So if you remember, you have the possibility to introduce temperature and atmospheric pressure for your particular location. Then you can test with RETScreen module the influence of this location in your case. So, well, now we have to conclude this webinar. Thank you very much, everybody. This has been a very interesting session. We have seen that small wind power is definitely something that many of you get interested, and we will have the opportunity to address the rest of questions on our website. We note that it's probably worth to come back with another session on small wind. Again, thank you very much. You're invited to come back to Leonardo Energy website, where you will find this webinar recording, the presentation, but also additional papers and documents like how-to manual on small wind. So now I say you goodbye and see you soon on these webinars. I take advantage also to announce the launch of Leonardo Energy in Spanish language. So go to Leonardo Energy and then check where we have this Spanish chapter, and we have also upcoming webinars in Spanish for Latin America Spanish and every Spanish speaker audience. Thank you very much and see you soon. Just a last announcement, as many of you like to interact between among the attendees, then I will resize the windows just to give you the opportunity to um, exchange and to network for some 10-20 minutes. Thank you very much.